depending on how much light there is, will change how much sound and blinkiness we get. So if I turn the light on, it'll get really slow. If I turn that off, it gets fast again, and then if I put my hand in front of it,
Okay, so the first step is turning it on, which I just did. And you can see when you turn it on, the power light should glow red like this. If it doesn't, that probably means you have a short and you want to take the battery out and turn it off as quick as you can and then try to find the short. But that's what it should look like when it's on. And the way that I have it programmed, the indicator lights on the wrists will just kind of shine steadily when it's turned on. But as you can see, the turn signals aren't blinking. But if I want them to blink, I press the the switch that's mounted on my wrist, like this, and I get feedback from the indicator LED, and you can see the turn signal starts to blink. And I can do that again. And if I want the turn signal to turn off, I can hit the switch again and it turns off. Of course, I can do the same thing on the left side, so turn it off. And I can also turn on both signals at once in this flashing nighttime mode, just so that I can be really visible when I'm riding by pressing both of the switches at once. And when I do that, I get feedback again on the indicator LEDs, and the turn signals on the back both flash. You can see here what's controlling everything is the lily pad Arduino mounted there in the middle of the back. And that's about it.
I'm Becky Stern. Last time I showed you how to get started with the LilyPad Arduino and how to make an LED blink. And this time I'm going to show you how to go another step further and make your whole messenger bag blink with, of course, an on and off switch. The theme of this year's Maker Faire is Remake America, so I chose to use these 12 red, white, and blue LEDs to put on my messenger bag for safety for riding my bike on my way home. The idea behind this circuit is pretty simple. I split one of the pieces of conductive Velcro into two halves, and then each of these is connected to, one is connected to the power source and one is connected to the LilyPad, and when this switch comes down across these Velcro pieces, it bridges the gap, providing power to the LilyPad, which will light up a sequence of LEDs around the patch. Here's a diagram I drew out for determining where the LEDs will go. You can download a computerized version of this in the blog post with the source code. But basically, the LilyPad is here, and each of the digital pins is connected to one of the LEDs, and then the other end of the LED is connected to this ground wire that goes all the way around the outside. Now I'm ready to use my conductive Velcro to bridge the power switch here and turn on the LilyPad. I already programmed it using the LilyPad programmer hooked up to Arduino on my computer, and there we go, a nice light show. So it's alternating, it's lighting up every other set of LEDs around the circle.